Hello everyone, welcome to our 10th week lesson. It already has been 10 weeks and today we're going to learn something fun. So last time we learned about binary code, how all the numbers or actually all data, files, videos, audio, text can be written in zeros and ones, and we learned about how to convert them into actually just numbers, numerical values into binary numbers. And hopefully you remember how to count binary number with, one hand. But anyway, today we're going to be talking about the following things. Oops. So today we're going to talk about mapping puzzle. It's a puzzle, it's going to be fun. Alphabets in binary, and I'm going to be deciphering binary. And we're going to do a little activity which will be used for next week's discussion group, okay? All right, moving on. Warm up. Try to decipher the following message. Pause the video and come back once you're done. Now, welcome back. So now when you see this, hopefully you realize that these symbols mean something, or usually maybe it's a shape, maybe it's a color, but hopefully you realize it's going to be color because what? All the shapes are the same, right? And hopefully you realize that each symbol represents a letter, right? So maybe this is red, and there are 3 symbols that make sense. Yellow has 6 symbols, which makes sense, and pink has 4 symbols. So maybe you thought each letter is like maybe R, E, D, red, right? You can confirm that by looking at other things. For example, this is E here. Is it E here as well? In this case, yes. What about here? Blue, hey, that works. So this is a thought process hopefully you followed, okay? So doing so, you get something like this, okay? So the answer is purple, so that the answer should be here, a purple color. All right, maybe that was easy. Maybe it was hard. Hopefully it was easy. I'm gonna do something else. Let's move on to the next. Binary language. So binary language, you can see 0 and 1s. And last time we talked about how numerical values can be written as binary, not decimal. In our everyday lives, we use decimal system, mainly because I think we have 10 fingers. But if we had 2 fingers, right, or 1 finger, right, I'm pretty sure we would be using binary system, right? But anyway, moving on. So let's look at these numbers. 0, 1, 1, 0, 1, 1, 1. Oops, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1. Oh, it's really hard to say. You can say if you want to, but I don't think there's a point. But how many binary codes do we have? Well, it depends, okay? But if you look at this, right? If you look at this, how many each numbers, how many digits are there? So let's count them up. So we have 1, we have 2, 3, 4, 5, I'm sorry, I'm writing 7 and 8, right? So each number has 8 digits. So do you remember what we call this? We call this 8 bits, okay? Because each digit represents what? A bit. A bit can hold either 0 or 1, okay? So this is 8 bits, okay? Oops, there we go. Whew. And guess what? Each 8-bit binary represents, in this case, a symbol or a letter or text. So in this case, this actually means hello. So in computer, hello is written in this form. You might think this is inefficient because, hey, what's the point of not writing H? But guess what? You got to understand this. Computers cannot understand letters, texts. It cannot. It understands binary, okay? At least for now, okay? All right, moving on. So what does that mean? It means each letter has its unique binary code, okay? And it's how many bits? 8 bits. So as you can see from A to Z, each letter has a unique what? Binary number. If you look at A to B, do you see that 1 has been added? And 1 has been added. So every time 1 is increased, okay? So let's go through this bullet point. Computers only understand numbers, 0 or 1. Okay, remember this is very important, okay? Now so what does that mean? Conclusion is that because computer does not understand anything but 0 and 1, we have to communicate with computer when you want to say something in text in zeros and ones. That's why people had to come up with a way to represent letters in numbers. And we call that ASCII system. Well, you don't say that way. I'm sorry about that. I think it's called ASCII system. So it's called American Standard Code for Information and Interchange. Basically what it does is it codes our numerical representation of text in computers. Now, if you click on this table, you can see all the symbols in ASCII, okay? So example is this. It's 8 bits, remember that? So letter capitalized A, the number is 65, but 65 in binary is this in 8 bits, okay? Now, small case, lowercase a is not same as capital, okay? So capitalization matters, okay? So lowercase a is 97, okay? And you can see that it's unique. It's still 8 bits, okay? So do you have to memorize this? No, unless you really want to, but it's easy to find online. Binary puzzle number 1. The following message contains the age of different people. Now, if my video is blocking the message, I'm sorry. Decipher and determine the age of everyone. So we have person A, B, C, and somehow person A, B, C gave us this code just to represent their age. So note this, we're not talking about text, we're talking about what? Age. We're talking about numerical value, okay? So pause the video and try to review what we learned last time to decipher this message. Welcome back. Hopefully you had some time to think about, maybe even review previous lesson. But here is hopefully something that you thought of. So as you can see here, person A is dark, bright, bright, dark, bright, okay? And if you look at every other person, it's either dark or bright, okay? So hopefully you thought maybe dark means low, because low in brightness, right? So maybe this is 0. And maybe bright is 1, and this is 1, and this is 0, and this is 1, right? Right? Hopefully. So this is off, right? So we don't care about this, off, and this is off, and everything else is on, right? But we know that each digit represents power of 2s. 2 to the 0 power is 1. 2 to the first power is 2, right? But it's off, so it doesn't really matter. 2 to the second power is 4. 2 to the third power is 8. And 2 to the fourth power is 16. So basically what we have here is we have 5-bit binary numbers, okay? 5-bit. Because why? There's 5 digits. So guess what? Person A is what? You just add them up. 16 you don't add because it's off. 2 you don't add because it's off. But 8, 4, 1, you add them, you get 13. So that means person A is 13 years old, okay? If you did not know how to do it, pause the video now and do B and C, okay? But if you already done it, you can continue watching. I'm going to show you the answer now. So the answer is, damn, there we go. Bam. Bam. There we go. Those are the answers, right? So yeah, binary can be written or symbolized in different ways, okay? So it doesn't have to be 1, 0. For machines, it's 1 and 0, but it can be different symbols. Now, puzzle number 2, right? An alien visited or visiting from Sirius system. Sirius is a star system near us. It's really bright, right? And left the following message for Earthlings like us that may help us to unlock their technology. Ooh, very exciting. Decipher the following message. Now, let's count the number of stars. By the way, you can pause right now so you can do it on your own, but I can give you a little hint, okay? Now, little hint. How many letters are there? Or how many characters are there? The first character is here, second, third, fourth, fifth. But most likely there are 5 characters, maybe numbers, maybe letters, we don't know. But let's count how many digits we have. 1, 2, 3, 4, 5, 6, 7, 8, I know my handwriting is really bad, but please know that I'm writing this on a trackpad. So yeah. So there are 8. There are 8 bits. Remember, 8 bits can be written as what? I mean, all the letters can be written as 8-bit binary. So most likely these are letters. So what I want you to do is go back and go to the table that contains all the letters and try to decode this. All right? Welcome back. Okay, if you haven't done it, it's fine, but I'm gonna show you the first one. All right, so dark is most likely 0, bright maybe 1, 0, 1, 0, 0, 0, 0. Right? So let's go back to the table. Give me a second. If you go back to the table, right, we have a bunch of zeros at the end. Yeah, here we go. 0, 1, 0, 1, 0, 0, 0, 0. It's P. You see that? It's P. So we know that the first letter is P. Now, if you now want to try, pause the video and come back. Welcome back. So the answer is, ta-da, psych. Anticlimactic, yes, but it must have been a hoax. All right. Now, exercise. Now, exercise I want you to do is write your name in binary code using the table in the link. So if you click on the link, okay, oops, discard, oops, it's okay. If you click on the link, you'll see, so if you click on the link, clicking, so we have a bunch of binary numbers, letters. You can find what letters you want in binary, okay? Okay, my computer is being slow, but it's okay. A lot of ads. Yeah, you can use it, okay? Ooh, computer, come on. This link is good. What you can do with this link is this. I'll show you. Click on this link. And this is translator, okay? For example, I can say, coding is very fun, right? And then, so use the ASCII. By the way, don't worry about the encoding yet, okay? And convert. And there we go, all this. So computer can translate this into coding is very fun with capitalization of C. So last time we started working on smart street light and we had the circuitry. Just to review, this is the light sensor that senses how bright or how dark the surrounding is. And we have 3 LED lights, red connected to number 10, yellow to 9, and green to number 11. Keep those numbers in mind as we go along. Now, also what we did was we completed up to second step. So when the photoresistor reads a value greater than 300, then we said, hey, turn on the red light, which is pin number 10, up to 100 value of brightness, and otherwise turn it off. And as a homework, I said, please complete this. So what it is saying is, hey, if the number from the sensor is greater than 200, turn on orange light, otherwise turn it off. And for number 11, which is green, turn it on when it's greater than 100. Okay, I know this translation is a little bit weird, but that's what they're saying. Okay, so what we can do is just to give you a solution. If you haven't done it, instead of getting all the elements again one by one, what we can do is we can right click or tab, just click on it, and then this will show up, duplicate. So we want to duplicate this how many times? Twice, because we want to do this for yellow and green, right? So for green, yellow, I'm sorry, 200, right? And yellow is number, I believe number 9. Let's go back, number 9, 200, good. Same thing, right? Number 9. And for green, I believe it's 100 value, right? And then this number will be 11. I know the numbering is weird. You can change them if you want to, as long as you're consistent. And feel free to do simulation, okay? Do quick simulation. Oops. One more time. And change the value, right? Change the value of the sensor. And remember, once it goes above, okay, the simulation has a limit to 100. So if you're in the simulation, what you want to do is you might want to change the values to 100, maybe 80, 60, or 40, because otherwise the numbers will not show. But for real purpose, you can leave the numbers as they are. So we're done with our block coding. And then what we're going to do is we're going to build the project and then implement this and see whether it works or not. Okay, let's go do it. Now let's build the circuit. The materials that we need are Arduino board, breadboard, power cable, adapter, jump wires, LED lights, and we need the light sensor. On the bottom of the sensor, you'll see 4 pins. And on the top, there's a component that detects the light intensity. First, we'll begin by connecting Arduino board to breadboard. 5 volts from Arduino board to positive row on the breadboard. Then we'll connect the ground GND from Arduino board to minus row on the breadboard. I will use red wire to connect 5 volt and black wire to connect GND, but you can change them if you want to. Now we'll connect light intensity sensor. Please use the diagram shown on the screen or refer to the app to get the legs properly connected, okay? So A0 pin from sensor to A1 on Arduino board. This is where the Arduino board is receiving the data from the sensor. Ground GND pin from sensor to negative row on the breadboard, and VCC pin from sensor to positive row on the breadboard. This is where power will be received. Now we'll connect LED to make sure LED lights, and make sure you correctly distinguish positive and negative side. Positive side is longer, remember that, okay? And we'll place them where the positive side will be on the right, okay? Always on the right, just to be consistent, okay? For all LED lights. So for red LED light, positive leg to pin number 10 as shown in the screen. Okay, and for yellow LED, connect the positive leg to pin number 9 as shown in the screen or the app, whichever you prefer. And lastly, let's connect the green LED light, positive leg to pin number 11 as shown in the screen. As you can see, I used red wire for red LED, yellow wire for yellow LED, and green wire for green LED, only just for people or for you to clearly see, but you can choose whichever color you want. To complete LED setting, we'll now connect negative leg of LEDs to negative row on the breadboard. So usually what I do is for VCC or anything power related, I use red, but for anything ground or negative row, I try to use gray or black so that it's consistent and it's clearly visible when you see it, okay? Now our circuit is completed. So now let's unload our block coding that we just worked on Arduino board. As you can see, the light sensor detects surrounding light intensity, and when it gets darker, it turns on more LED lights, as you can see. Well, this is it for our lesson today, and thank you everyone. See you all next week. Bye bye.